Welcome back to Mr. Vaughn's classroom, where he makes math so easy, even I can do it.
Before we get started on today's lesson, I'd like to ask you to please give this video a thumbs up, subscribe to the channel, and engage with a comment below. This video is looking at Unit 3 on Similarity, Lesson 4, Dilating Lines and Angles. The learning goal in this lesson is to dilate lines and angles. We have one learning target in this lesson, and that says I can explain what happens to lines and angles in a dilation. And what we're going to look at is that while lines get bigger by multiplying by the growth factor or the scale factor, angles don't actually change. The lines get longer, but the angles stay the same. For glossary terms, we're going to start with dilation. A dilation with center P and positive scale factor K takes point A along the ray PA to another point whose distance is K times farther away from P than A is. Triangle A prime, B prime, C prime is the result of applying a dilation with center P and scale factor 3 to triangle ABC. So the blue triangle ABC is the original, and the green triangle A prime, B prime, C prime is the image. Notice when you compare them, the lines are longer by a multiple of 3, but the angles themselves are still the same. Our other glossary term is scale factor, the factor by which every length in an original figure is increased or decreased when you make a scaled copy. For example, if you draw a copy of a figure in which every length is magnified by 2, then you have a scaled copy with a scale factor of 2. Notice that right in this definition, it says every length is increased or decreased. They don't mention increasing or decreasing the angle. So if you look on the left, the smaller figure is the original figure. On the right, the larger figure is the image, the scaled copy. And while you can easily tell that the lines are each 2 times longer, you can also easily tell that the angles are the same. If you took that original figure and you slid it over and you put each angle on top of the image angle, you would see that the beginnings of the lines in those angles would be directly on top of each other. They would just get twice as long. Now that we're done with the introduction, let's go ahead and take a look at the first practice problem.
Let's turn up the heat on this equation. A little bit of multiplication here, a pinch of division there, and voila!
Practice problem number 1 says that angle ABC is taken by a dilation with center P and scale factor 3 to angle A prime, B prime, C prime. The measure of angle ABC is 21 degrees. What is the measure of angle A prime, B prime, C prime? So let's draw the original. Let's say we have an angle A, B, C. Now, let's say there's a point P somewhere along here. So if I have a scale factor of 3, then I take point B and I move it 3 times farther away. So maybe I move it to 1, 2, 3. Let's say B prime is now out here. And then let's say C prime is now going to be 3 times farther. So I go 1 distance, 2 distance, 3 distance. And maybe now my C prime is somewhere out here. And then if I look from P to A, and I say, okay, well now I'm going to make it 3 times farther. So 1, 2, 3. And maybe it's somewhere around here. And so now I have A prime, B prime, C prime. Well, what you notice is that, yes, the lines get 3 times longer. So maybe we say that this was 1 and this was 1, and the angle in here was 21 degrees. Well, when I extend everything by a scale factor of 3, then the top line goes from being 1 unit to being 3. And the bottom line goes from 1 unit to 3. But this angle inside is still going to be 21 degrees. The angle doesn't change, just the lengths of the lines. So angle A prime, B prime, C prime still equals 21 degrees. Remember that when you are scaling, it is the lengths of the lines that you are scaling and not the angles themselves. The angles stay the same, the lines get longer. I hope this helps make sense of this question. If you do have any questions, please leave a comment below.
I'm once again asking you to solve this equation, and don't tell me we can't afford to get to the answer.
Practice problem number 2. Select all lines that could be the image of line M by a dilation. So it's important to remember what a dilation is. A dilation is moving points further away from a center point or closer to a center point, depending on your scale factor. What it's not going to do is it's not going to rotate a shape. So I'm going to make that note right up here. Dilation moves points farther from a center or closer to a center. It doesn't rotate. So if I look at L, L has rotated. It has done this counterclockwise rotation. So A could not be the image. Next, if we look at M, M is M. If I multiplied every point on M by 1, no matter where the center is, every point would stay the same. So B could be an image of itself by multiplying every point by 1. The next choice is N. Depending on where your center is, this might have pushed it farther away if your center was over here in the upper left. It might have pulled it closer to if your point was down in the bottom right, but it doesn't rotate. It simply shifts it closer or farther from the center. And that's exactly what an image would do. It just simply slides. The fourth option is O. To go from M to O, you would have to rotate it. And remember, we said that images do not rotate. They simply move closer to the center or farther away from the center. And our last option is P. If I wanted to go from M to P, this is just a straight shifting. If my point for my center is somewhere up in this upper left, then we moved it farther away. If my center is somewhere down here in the bottom right, then we moved it closer to, but we didn't rotate. So this shifts closer or farther from center. And that's exactly what a dilation does. So even if we're talking about a straight line, we can still tell a dilation because the dilation is simply going to move points towards the center or away from the center. It's not going to rotate the shape. I hope this helps make sense of it, but if you do still have any questions, please go ahead and leave a comment below.
We're going to solve this problem not because it's easy, but because we need to get to Mars.
Practice problem number 3. Dilate line F, which is the blue line, with a scale factor of 2. The image is line G. Which labeled point could be the center of this dilation? So the first thing we need to understand is that 2 is greater than 1. Because of this, G is shifted farther from the center, which means we must be traveling in this direction. And the only point that is back here on the bottom right is point D. Point A means the line would be shifting closer. Point B would mean that the line was shifting closer. Point C would mean that the line would have to stay the same. If anything, it would just get longer but stay in the same place because every point would be moving out from C. D is the only one where if this was the center, every point on F is now pushed out to where it is on G. So D is the correct choice. Remember that when you have a scale factor, if it is a fraction between 0 and 1, then it shifts closer to the center. If it is 1, then it shifts nowhere. It stays the same. And if it's bigger than 1, it shifts away from the center. That's how we know it must be D, because for the line to go from the blue line to the green one, it must be shifting away from something in the bottom right, and D is the only point down in the bottom right. I hope this helps you understand this better, but if you do have any questions, please go ahead and leave a comment below. Just to quickly review the learning target for Lesson 4. This one says that you can explain what happens to lines and angles in a dilation. So the first part of that is what happens to lines. Okay? The points on the lines are either getting closer to the center point if you multiply by a fraction between 0 and 1, staying exactly where they are if you multiply by 1, or they're getting farther away from the center if you multiply by more than 1. So with that in mind, the lines are either getting shorter, the lines are staying the same, or the lines are getting longer. However, the second part of that statement is about the angles. The angles are not changing. So just like that first practice problem, when the angle started at 21 degrees, even though the lines got longer because the points shifted farther away from the center point, the angle still stayed at 21 degrees. So I hope this has all made sense to you. If you still have any questions, feel free to leave a comment below. If you found this video helpful, please give it a thumbs up. If you find these videos to be helpful in general, then in the bottom left you'll see another video that YouTube is recommending to you. And in the bottom right, you'll see the subscription button for the channel. It would really help if you would subscribe. I look forward to seeing you in the next lesson.